Good afternoon to all of you. Today we will discuss integral equation. What is the basic definition of integral equation? An integral equation is an equation in which an unknown function appears under one or more integral sign. For example, integral a to b kxt yt dt, where kxt is the kernel of the integral, yt is the unknown function, or fx is equal to yx minus lambda integral a to b kxt yt dt. What is x and t? X and t lies between a and b, where fx and kxt are unknown function. This fx and kxt are fx and kxt are known function, and lambda ab are constant, and yx is known function. The type of integral equation: there are basically two types of integral equation: linear and non-linear integral equation. An integral equation is called linear if it satisfies the law of linear transformation. For example, if we define Ly is equal to integral a to b kxt yt dt, or Ly is equal to yx minus lambda a to b kxt yt dt, if it satisfies this condition, L of alpha 1 y1 is equal to alpha 1 ly1 alpha 2 ly2 for any arbitrary constant alpha 1 and alpha 2, whether it is real or complex. Equation number 4. If gx is 0, an equation is known as Fredholm integral equation of first kind. If gx is equal to 1, then yx is equal to fx plus lambda a to b kxt yt. This integral equation is known as Fredholm integral equation of second kind. If gx does not equal to 0, for example, gx does not equal to 0 and does not equal to 1, then equation 4 is FIE of third kind. Homogeneous Fredholm integral equation of second kind, a linear integral equation of the form by setting fx equal to 0 and gx is equal to 1. Fx is 0 and gx is 1 in this equation. Set fx is equal to 0 and gx is already 1. This gx is 1. Then this equation is known as Fredholm integral equation of second kind. Volterra integral equation, a linear integral equation of the form this is the general form of linear integral equation, but upper limit is variable. This integral equation is known as Volterra equation. Volterra integral equation of first kind. If gx is equal to 0, then above equation converted into Volterra integral equation of first kind. If Volterra integral equation of second kind, if gx is 1, and if gx does not equal to 0 and gx does not equal to 1, then integral equation is known as Volterra integral equation of third kind. Remember that if this upper limit is variable, if this is variable, everything is same, and this integral equation is Volterra integral equation. If this upper limit is constant, then this is Fredholm integral equation. Homogeneous Volterra integral equation. Let us consider fx equal to 0 and gx is equal to 1. Then integral equation converted into this form. This is known as homogeneous Volterra integral equation. There are some specific function of the kernels. If kernel satisfy this condition, kxt is equal to k bar tx, means interchange variable x and t, function remains same. If it is complex, then this is if it is real, then kxt is equal to ktx. Otherwise, taking conjugate of this, then this kernel is known as symmetric kernel. What is separable kernel or degenerate kernel? A kernel kxt is called separable or degenerate kernel if it can be expressed as sum of, if it is expressed sum of finite number of terms, sum of finite number of terms, each of which is product of a function of x only at function of t, means kxt is written in the form of this g summation over I from 1 to n gix hit, where the function gix is linearly independent. Remember that this function is linearly independent function. For example, x and e to the power x square is to a linearly independent function. Integral equation of convolution type. What are the convolution type integral? Special. This kernel is of special type. If kxt can be written as kx minus t, means kxt is the function of x minus t. Is the function of x minus t. That is, what is the equation? Yx is equal to fx lambda ax kx minus t yt dt. Here kx minus t, it is the kernel of convolution type. This is convolution kernel, convolution type kernel. Fx is equal, yx is equal to fx lambda a to b kx minus t yt dt. This is Volterra integral equation and it is Fredholm integral equation. Iterated kernel. What is iterated kernel? Consider a Fredholm integral equation of second kind. Yx is equal to fx lambda times yx is equal to fx lambda times a to b kxt yt dt. Yes. Then how kxt is known as iterated? Start by the iteration process. Whatever the kxt is given, write it k1xt. Kxt is assigned in k1xt. Then what is k2xt? K2xt can be written as integral a to b kxz. Remember kxt, replace t by z into k1 zt dz. In k1xt replace x by z, and in first term replace t by z, in second one replace x by z. It is n is equal to 2. We are evaluating k2xt, then it replace n by 2 k1 zt. This type of kernel is known as iterated kernel or repeated kernel. Resolvent or reciprocal kernel. Integral equation of the form this or this is said to be a resolvent kernel if kernel can be written as this type rxt lambda. Everything is same as the integral equation. Yx is equal to fx plus lambda integral a to b rxt lambda f of t. Remember that yt is replaced by f of t. Then this integral equation with resolvent kernel. This rext lambda is resolvent kernel. Resolvent kernel. And if yx is equal to fx in Volterra integral equation, yx is equal to fx plus lambda times a to b gamma xt lambda ft dt. Then rext lambda gamma xt lambda is known as resolvent kernel. What is the solution of the integral equation? These are the integral equation. Then how we find the solution of this integral equation? Let the integral equation of the type this. Consider this type of integral equation, means Fredholm type of integral equation or Volterra type. This is FI and this integral equation is BI. This is Fredholm integral equation and Volterra integral equation. A solution of integral equation 1 or 2 is a function yx which when substituted into the equation reduces to the identity with respect to x. For example, if we put yx in terms of yt and put here and solve this term, we get LHS. Then this yx is known as solution of the integral equation. Now, for example, let us consider one example. So that we have to show that this function is the solution of this integral. Which integral? This is the integral. This is Volterra integral equation. Volterra integral equation. We have to show that solution of this integral equation is this. Let yx is equal to this 1 plus x square minus 3y2. If yx is this, then what is yt? Yt is this. Yx is given. Replace x by t. We find yt. Using equation 3, we can solve 1. How? Let us consider RHS. RHS of 1. 1 upon 1 plus x square minus 0 to x. T upon 1 plus x square. What is yt? 1 plus t square 3y2. 1 plus t square 3y2 dt. Put t square is equal to u. Then 2t dt is equal to du. Or t dt is equal to du by 2. Right? And 1 upon 1 plus x square minus 0 to x square. What is x square? 1 upon 1 plus x square 1 plus u minus 3y2. Right? Here t and x are same. If t square is equal to u, means u is equal to x square. Put limit in terms of u 0 to x square 1 upon 1 plus x square. T dt is equal to du by 2 and 1 upon 1 plus t square is u whole to the power minus 3 by 2. Right? After solving this integral, this is constant. It is free from u. Then this can be written as 1 upon 1 plus x square minus 1 upon 1 plus x square into integral 1 plus u minus 3 by 2. Consider 1 plus u is equal to z. Then du is equal to dz. Z to the power minus 3 by 2. Then this integral become minus 1 by 2 divided by minus 1 by 2. The limit 0 to x square and solve this. This is equal to 1 plus x square whole to the power 3 by 2. This is LHS. LHS. Start from RHS, we find LHS. Means this yx satisfy this equation. Put yx in terms of yt here and solve this RHS term. If we find LHS, then this yx is the solution of the differential equation. Another example. So that yx is equal to x e to the power x is the solution of this Volterra integral equation. See, yx is equal to x e to the power x. Then what is yt? Yt is equal to t e to the power t. Put this yt here. This yt here. Then this equation in the form yx is equal to this, yt is equal to this. Then RHS of equation 1 is sin x 2 0 to x cos x minus t t e to the power t dt. Now integrate this term. This term integrating by parts. Integral of cos x minus t t e t dt 0 to x. integrate this term by integrating by parts and adding sin x. We find this as x e to the power x. What is this? This is equal to yx, that is LHS. Solving RHS, we find LHS, means yx is equal to x e to the power x is the solution of the differential equation. These two problems shows that how to verify a given function is the solution of the differential equation or not, right? So that the given function are solution of these functions. Here are some examples. These are the homework. Next lecture we will discuss another type of integral equation. Okay, thank you.